In section 8.3, we're looking at showing a quadrilateral is a parallelogram. This is very similar to what we looked at in 8.2, but we have to be careful in what the question or what the general focus actually is. If we take a second to think back to 8.2. In 8.2,
Grace Van please report to attendance. Grace Van please report to the attendance office.
You were given, here's a parallelogram, and you had to list or know the 5 properties that came with it. The 5 properties, which you hopefully know: opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So, you got a parallelogram, here are the properties you know, and we solved problems with that. In this section, a general focus we're going to have is you have a quadrilateral. What we need to find is the ways to make it into a parallelogram. Hence why we're showing, or we could be proving, that we have a parallelogram. So do we have enough in this general shape to make it into a parallelogram? The 5 properties do not transfer exactly. We're going to have close. Some will match up exactly, and they're those biconditional if and only if statements. But we have to be careful. We have a quadrilateral. Do we have enough to be a parallelogram? Now, we have some new theorems to go over, and then we'll put them all together and look at all the ways we have together. But in 8.7, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So, opposite sides congruent would be enough. So if ABCD, well, let's rephrase that. We want to say both sides. So if AB is congruent to CD and BC is congruent to AD, then ABCD is a parallelogram. And instead of writing parallelogram, I'm just going to draw that little symbol that tells us it is a parallelogram. 8.8 says if both pairs of opposite angles are congruent, so A and C are congruent, B and D are congruent, then the quadrilateral is a parallelogram. So if angle B is congruent to angle D, and angle A is congruent to angle C, then ABCD is a parallelogram. 8.9 is a little bit different, not quite what we saw in the previous section. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So if we say these two sides are both congruent and parallel, so BC is congruent to AD and BC is parallel to AD, then ABCD is a parallelogram. Now, this is different. This is kind of a departure of what we had so far. So we don't need to really necessarily know anything about AB and CD. We know we have the parallel sides. We know we have the congruent sides, and that will be enough to say it's a parallelogram. Now, this doesn't quite work in the opposite direction. We didn't really have this one. We were talking about both sides, but this is that new one we have where that's enough. We don't necessarily have to know anything about AB and CD as long as we have a parallel side and angles between one pair. Okay, last one, if diagonals bisect each other, then the quadrilateral is a parallelogram, same as the one we've seen last section, and this time label that E. So if BE is congruent to DE and AE is congruent to CE, then again ABCD is a parallelogram. So let's put these all together and look at the actual list we have. So these are our ways to prove a quadrilateral is a parallelogram. These are the 4 we just mentioned in the theorems. The first one, which we have anyways because that's the definition of a parallelogram, is that opposite sides are parallel. So these are the 5 ways we prove to have a parallelogram. If we look at a general shape and it asks us, is this a parallelogram? And our answer is yes, it needs to fit one of these categories. Remember, not to use it looks like. That doesn't work for us. So these have to fit. This would be enough to get there. Now, the ones that work are properties in a parallelogram are those four. Now, that fourth one doesn't work. If we went back to the properties for a parallelogram and we listed it there, we would have switched out this one and replaced it with consecutive angles or supplementary. Consecutive angles or supplementary doesn't work as a way to prove it's a parallelogram because that could be a trapezoid, which we find out later is not a parallelogram. So this is the one that replaces it. So these are the five we can use. As we look at the examples, as you go forward doing the homework, you have to have used one of these as a reason to prove it's a parallelogram. So here's some good examples we have to it. First, why is this a parallelogram? So if we're going to say it is, we have to have a reason. I look at my first one. I have hundreds as opposite angles. I have these congruent angles here. Maybe I could take the fact that the total is 360, find what's left over, and find those two angles. But really the question is, why would I do that? Because if I did that, I'd be looking for consecutive angles. We don't need consecutive angles. This is a parallelogram because opposite angles are congruent. If we look at this next one, we look at the sides, the 20 matches up, 14 and 14 matches up. That is a parallelogram because opposite sides are congruent. Our third one, that has to do with diagonals. The only one we have with diagonals is that they do bisect each other. It looks like we have one mark there, those match, two marks there, those match, so diagonals bisect each other. Now, if we move down here, we see find the value of x. Find what value of x is the quadrilateral a parallelogram. This is where we change the question. This is how we're going to get our solve for x type problems in this section. Last chapter or last section, when we looked at properties, we could have changed this question and it could say find the value of x in the parallelogram. We do the same process, but now we just rephrase it a little bit because for these values to be equal and it bisect each other, we have to find what value of x works. So 4x plus 2 equals 5x minus 6. We subtract 4x and we get x minus 6 and 2. We add 6. We get x equals 8. If we check real fast and plug that in, 4 times 8 is 32, plus 2 is 34. 5 times 8 is 40, minus 6 is 34 as well. So if x is 8, these are both 34. The diagonals bisect each other, and we know it is a parallelogram. Next one, we have 6x equals 3x plus 2. I subtract 3x from both sides. I then divide by 3, and oh no, I get 2/3. Yes, that's still a correct answer, even though it's a fraction, even though it didn't come out to be a whole number. Let's not be afraid of fractions. There's nothing wrong with that. 2/3 as a value would give us 4 if we substitute it into 6x, and it would give us 4 if we substitute it into 3x plus 2. Those values would be equal, so that is the value that would work for a parallelogram. As you go forward doing the problems, remember for this section, these are the 5 properties you need to know to prove it is a parallelogram. The only difference before making a biconditional statement to what we did in the previous section, the properties when you have a parallelogram, is to switch out number 4. This only works in this section. The fact that consecutive angles are supplementary works in the previous section. So, good luck.